One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and it's the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey everybody, and welcome back to the Inflammation Nation. We're still talking about detox and my approach to detoxification, which I call the 3D detox. And I want to jump ahead a little bit and talk about the third D, which is DEEP-Tox. I think I've already laid the foundation of how it's very important to have a systematic approach to detoxification. And while in some cases it might be appropriate for someone to just go out and buy some liver support product or milk thistle, or to have some kind of a simple detox program assigned to them by some kind of a healthcare practitioner, the vast majority of people listening to the Inflammation Nation podcast are in a metabolic state where there's just more at stake. There's more stuff going on. Their cases and their situation is more complicated, more complex. And so we really have to be intentional about how we approach clearing the body of metabolic insults like heavy metals or environmental chemicals or things like mycotoxins. And again, we can't just jump in and say, okay, we're going to do a detox and support the liver and think that we're going to be doing as good a job as possible and potentially minimizing the negative or the downside consequences of doing that. And so what is that third D? If you remember, the first D in the 3D approach is deload, or what I commonly call pre-tox. Again, those are the things that you do before you actually do the detox, which is the second D, the detoxification. And that can be as simple, literally, as just, taking some liver and gallbladder support products. And there's any number of them out there. You can just go to the health food store and buy those things. But again, it's a very oversimplified approach, which runs the risk of not being robust or well thought out enough for someone who's part of the nation. And then the third D is in recognition that when we harbor toxins inside our body, that these toxins get stored deep in fatty type tissues. And also there is metabolic consequences like the impact of toxins on cell health. And so the DEEP-Tox basically refers to the ultimate goal, which is not just to have a controlled and non-reactive chemical burden, but to have a physical body structure that has integrity in the sense that it's not embedded full of toxins that have caused some kind of cellular damage. And we'll talk very briefly today about how toxins do affect cell health and why this is important. But one of the things that I want to remind you of, because I mentioned this, I think it was in the last episode, is that toxins, because they are fat-soluble molecules or compounds, they get attracted to where fat lives. And that means in your body fat. And we can break that down into both subcutaneous fat, the stuff that's literally just under the surface of the skin, as well as visceral fat, which is fat in your body cavity surrounding your internal organs. And that's concentrated in certain areas. It's certainly not everywhere, but over time it can develop into that for sure. And also, we can see toxins being incorporated into the fatty component of certain organs. We'll come back to that. And because your cells have a cell membrane, which is a protein, lipid, or fat combination, these toxins actually get attached to the cell membrane and can change how the cell functions, as well as the health of the cell. And then probably what is a very little known fact about chemicals and environmental chemicals and heavy metals is that they also circulate attached to what are called your lipoproteins. And you may have heard that word before, but we're talking about things like LDL cholesterol or HDL cholesterol, because they are made up of fat themselves, or I should say they have a fatty component to them, because LDL and HDL is not the fat. These are lipoprotein carriers. because they actually have a fatty component, you can have aspects of your total cholesterol picture circulating around your body that have chemicals attached to them. Now, we typically look at that as a protective mechanism. The downside, and when I say that, it's as if your LDL and HDL cholesterol, part of their function is to actually scavenge toxins that are in your body so you can eliminate them. The downside is that when you have things like LDL cholesterol, which is, and I'm going to use this term very loosely, considered the bad cholesterol. I'll probably end up having to do a series of episodes on that. But if you have LDL cholesterol, quote unquote, the bad cholesterol, circulating around with chemical toxins attached to it, it tends to drive inflammation and oxidation, which then promotes risk for things like cardiovascular disease. And so on one hand, it's good to have enough cholesterol to participate in binding and excreting and neutralizing toxins, but there's a potential risk for that if you're not able to excrete them fully. So again, the whole point of doing a DEEP-Tox is to make sure you get to the point where your chemical burden is under control. And I mean that in two different ways. One, quantitatively, how much do you have? Is it under the threshold that we think is safe? And qualitatively, meaning that if you start out with some kind of immune response to your chemical burden, then we need to quiet that down. And the downside of doing a detox too quickly, just to get the quantity down, when someone has a qualitative immune response to these chemicals, is that when you pull things out of deep storage in your fat or your fatty tissues and put them into circulation, you run the risk of driving systemic inflammation, which can then promote all of your core symptoms, but certainly can be triggering and perpetuating factors for things like autoimmune reactivity of any kind, no matter what tissue, whether it's your thyroid or your brain or anything else. So one of the things that we want to think about is actually how do toxins actually get into your cells, right? We understand how they get into the body. We breathe them in, we swallow them, they get absorbed through our skin.
Noseworthy.
But how, once they're inside, how do they get into your cells? Well, first of all, they can actually be absorbed through the cell membrane. Remember that the membrane of the cell, the outer layer, if you will, is made up of a lipid type structure. They call it a bilipid layer. And so they can attach themselves to the cell membrane and actually get absorbed through a couple of different mechanisms. We also know that certain cells have toxin uptake receptors, and we might argue that that is part of the natural design so that the cell can itself scavenge a toxin and then potentially signal to the immune system that it is containing some kind of a toxin load, so the immune system can basically destroy the cell and get rid of it and soak up and eliminate the toxins that were engulfed by the cell itself. So there are toxin intake receptors. Now, in some cases, these receptors are not functioning in that natural design perspective, but the chemical nature, the molecular structure, if you will, of a toxin may match the thing that normally attaches to that receptor. It would be like, you have a car that has a certain key that opens the door and turns on the ignition. And if I just happen to have a key to something else that looks exactly like your key, I can open your car and turn your car on and then drive it away. And so sometimes the chemical nature of these toxins is such that it mimics the activity of whatever binds to the receptor. And so it can get absorbed that way as well. And this is the same concept as things like endocrine disrupting chemicals or obesogens. They can bind to things like thyroid and estrogen receptors. We can also have toxins entering the cell by causing cell damage. Remember, these things are pro-inflammatory. And whatever else these chemicals do, they drive inflammation and they deplete glutathione. And those two things can destroy or damage a cell membrane, basically opening up a doorway or a channel of entry that didn't exist before. And then sometimes the final way that toxins enter a cell, and technically it's not entering the cell, but they kind of get stuck in the cell membrane themselves. Remember, these chemicals and these toxins love fat, and they like to be where fat is. They attach themselves to fat molecules. And because the cell membrane itself is or has a fatty composition, then the toxins can actually attach and stay in the cell membrane. And what that does is it changes the characteristics of the cell membrane, part of which is things like fluidity. And so a toxin laden cell membrane all of a sudden can't pass things in and out of the cell, which is part of the normal cellular function. And so the behavior and the characteristics of cell function can begin to change there as well. So we've already talked just a little bit about how some of these toxins can have impacts on cell health and cell function. I want to talk about 4 specific things, and I'm not going to go into tons of detail. And again, at some point, more detail doesn't change what you do. And so in most cases, it suffices just to talk about concepts and principles, especially in the context of a podcast like this. But again, there are 4 main areas where toxins impact cell health. Number 1 is the overproduction of something called nitric oxide. And I'll just give you all 4, and then we'll come back and just say something briefly about each one. The second one is the production of reactive oxygen species, or what we call oxidative stress. Another one is mitochondrial dysfunction, which has implications for cellular energy and also potential damage to DNA. Let's talk about nitric oxide first. Very briefly, nitric oxide is a signaling molecule that can be produced by neurons in the brain or the nervous system. It can be produced by the cells that line your vascular system, called your endothelial cells. And it can also be produced by certain cells of the immune system. And what ends up happening in most cases when we have these chemicals is that we get overproduction of nitric oxide from your immune system. And that's of particular importance because under normal circumstances, your immune system uses nitric oxide as a defense strategy to kill things. And just imagine, if you will, and I use this analogy or this mental picture in seminars when I teach doctors about this. If you've ever seen like an old-time war movie, you've probably seen a scene where a soldier climbs up onto an enemy tank, lifts up the hatch, throws in a grenade, jumps down and runs away, and then the tank explodes from the inside out. That's basically what nitric oxide is when it's produced by the immune system. The immune system, the cells will actually poke holes into some kind of a foreign invader, inject things like nitric oxide. It can use other things like hydrogen peroxide as well, creating what's called a respiratory burst. And the large amount of nitric oxide injected suddenly to the interior of an organism will kill it. And there's different mechanisms that are irrelevant at this point. But the point is that when we have these chemical toxins or these toxins impacting cells, we get this respiratory burst, this massive increase of nitric oxide production, which can cause damage, if not death, to the cell. We also talked about one of the other impacts is reactive oxygen species and oxidative stress. And one of the reasons why that happens is because these chemical toxins tend to deplete the production of glutathione. We've talked about glutathione levels going down, and one of the consequences of that is an increase in the production of free radicals. And those free radicals then can dysregulate the cell's metabolic functions and then start causing damage to the tissues, which means now we'll jump to number 4, which is the potential to damage the DNA. And so when you have these chemicals causing increased inflammation and oxidative stress, changing how the cell functions, if you alter the DNA, then if that cell survives and then replicates, then you get a new cell that has damaged DNA. And along with that comes changes in its functionality as well as its potential lifespan. And then finally, and this was the third one on the list, and this was mitochondrial dysfunction. And this is potentially also a consequence just of the inflammatory cascade, but certain chemicals have other, let's call it chemical properties, that have the ability to alter how your energy production systems work. And what ends up happening is if a cell can't control inflammation, if a cell can't control oxidative stress, and if a cell can't produce energy, that environment actually is a biological signal to the cell for what we call death pathways to be initiated. Kind of like, think of it like a self-destruct. Again, using movies as an analogy, maybe it's a James Bond movie. Some kind of a bomb or something has a self-destruct mechanism on it. And cells are exactly the same way. And this is part of the intelligent design of the human body, as well as animals, is that if a cell senses a chemical environment that suggests disease or some kind of defect and severe dysfunction, it will hit the self-destruct button so that it encourages the immune system to get rid of it. And so we actually end up with, again, cell destruction and cell death. And I also, I said a minute ago, and I've said this in other episodes, that these toxins tend to accumulate in fatty tissue and organs that contain a fatty component. And of course, we think immediately about body fat. We think about cell membranes. So think of toxins embedded in the cell membrane scattered throughout your entire body, contributing to your entire toxin load. We also have these toxins accumulating in organs that have high fat content. For example, bone marrow is about 70% fat. Your brain is about 60% fat. And if you look at studies, there's actually a great series of studies that have been published over the years that look at things like chelation therapy. And if you've not heard of chelation therapy, you can do oral chelation, where you take certain chemicals that are known to bind to toxins to eliminate them. Things like EDTA, for example, you can get that in oral doses. But also intravenous chelation, which is probably the most common one or the most well-known. And it can be terribly expensive depending on which part of the country you're in. You have to do it over and over and over again to get to the point where your chemical load is controlled. But if you look at the studies that look at the impact of using chelation therapy on toxin clearance, certainly we have studies that show that using different types of chelation strategies increases the excretion of certain heavy metals or environmental toxins. But what we also see in those studies is that as chemicals and toxins are pulled out of storage in fatty tissue that circulate around, that we cannot eliminate, just get redistributed to where the fat lives. And that is back in your bone and back in your brain, and perhaps even in your liver. And so this is a word of caution to anyone who's thinking about doing chelation therapy. Number one is ask yourself, are you really ready for this, right? You need to know whether or not you have a qualitative immune type response to some kind of heavy metal or environmental chemical, because if you do, when you use chelation therapy to get rid of it, the things that you can't eliminate that recirculate and eventually get deposited in bone and brain can fire off and trigger systemic inflammatory responses. And so chelation therapy, for all its wonders and all the good things that it can do, can be very, very devastating to the wrong person. And so just caution is warranted. Now, the final place where toxins can bioaccumulate is organs that also tend to accumulate fat. So maybe, we just talked about how bone marrow and brain is 70 or 60% fat respectively. But what about things like your liver and your pancreas? If you've heard of something called fatty liver before, then you understand what I'm talking about. And this is very commonly associated with things like insulin resistance and hyperglycemia, high carbohydrate intake, high fruit intake, the consumption of fructose, like high fructose corn syrup, which of course is a large source of calories in the standard American diet. But while the liver itself doesn't necessarily have a huge fatty component to it, there can be diet and lifestyle factors combined with some genetic predispositions that lead to the accumulation of fat in the liver. And so, yes, the liver can accumulate toxins, but really, in essence, only to the extent that you have some kind of fatty deposition. And these are things that we can figure out using lab testing or diagnostic imaging, for example. But just like you have fatty liver, you can also have fatty pancreas. And this is not something that's really ever talked about in the clinical setting, but it's certainly published in the medical literature. So let me just go through that one more time. Toxins can accumulate in body fat, in your cell membranes, in organs that contain high fat content like your bone marrow and your brain, and organs that tend to accumulate fat like your liver and like your pancreas. And on the heels of that, it's probably worth mentioning or going back and just giving a little bit more detail on the body fat part of that picture. Because I said earlier, we have body fat, we break that down into two different components. So that's subcutaneous fat and then visceral fat. Most of the visceral fat is surrounding your gut and your liver, and you're likely to have high visceral fat. Let me just give you some metrics that you can assess yourself with. But we can look at things like waist measurement for the average man, average woman. Obviously, if you're very petite or if you're very large bone structure, really tall, These numbers might be a little bit off. So this is for the average population that is not on either end of those extremes. But you are likely to have high visceral fat, which is the unhealthy type of fat, if your waist measurement, if you're a woman, if your waist measures more than 35 inches, or if you're a man, your waist measures more than 40 inches. And these metrics can also be part of, using to determine if you have things like metabolic syndrome. But nevertheless, in general, for the average person, if you're a woman and your waist is more than 35 inches, chances are you have not just subcutaneous fat under your skin, but you have a high visceral fat load. And if you're a man, you probably have a high visceral fat load if your waist measures more than 40 inches. Now, why is this important? Well, on one hand, fat cells sequester toxins to prevent them from interacting with and damaging more cells while they circulate through your body. But on the other hand, the more fat you carry, the more toxins you can store. And these toxins can constantly leach out of your fat cells, which accelerates during things like chelation therapy or detox, or even during fat loss. And you may have experienced this yourself. I'm not going to say it's a very common thing, but it's common enough that clinically we think about this in certain cases, is that sometimes people will go through rapid fat loss, which they typically accomplish by severely restricting their calories, et cetera, et cetera. And sometimes they feel great for maybe a few days, maybe a week, and then all of a sudden they hit a wall, and sometimes they can feel worse and they gain back the weight that they had just lost. And if you feel like you get flared up and then rebound weight gain when you go on a rapid or aggressive fat loss regimen, then chances are what's happening, at least part of what's happening, is you're rapidly releasing toxins that were in storage that did not have the ability to circulate in your body and kind of mess up your metabolism. And one of the things to understand about this is that fat cells are fairly long-lived. Fat cells actually have a very slow turnover rate. It takes about 8 years to replace only 50% of your fat cells, which means when you store toxins in your body fat and your visceral fat in your cell membranes, while we're talking about fat stores specifically, that toxin load hangs out for a very, very, very long time. And as your fat cells turn over and they spill their contents, if you can't bind, neutralize, and eliminate those efficiently, they're just going to get redistributed back to your body fat, into your bone, into your liver, maybe into a fatty, or not your liver, into your brain, maybe into a fatty liver or a fatty pancreas if you have that. And I'm going to end today's episode just by talking about some of the impacts of these toxins, not just on cell health and function like we just talked about, but just kind of in the broader sense of things. Toxins can alter your body morphology, meaning that it's very easy for a chemical load to increase your body weight, increase your fat mass, drive inflammation, and then reduce your glucose tolerance and your insulin sensitivity. All of that basically spells metabolic disaster. We also know that toxins can have an impact on your fat cells themselves. Number one, it can trigger the expansion of your fat mass. Now, let me pause here so you can get your head around that. Your fat mass, how much body fat you have, can grow through one of two different mechanisms. One is the fat cells that you have can get bigger. That's called hypertrophy. And bigger fat cells can store more toxins, and bigger fat cells tend to be metabolically unhealthy. They can create inflammation. They can secrete hormones that cause problems in other areas. Or you can expand your fat mass through what we call hyperplasia. And that means more cells, but the cells are healthier and they're of normal size. If your fat mass expands, it's much better to expand your fat mass through hyperplasia, adding more cells that are normal and healthy in function, than it is to take the cells that you have and make them bigger so that they can store more toxins, become more inflamed. We also see with these adipocytes or fat cells that toxins can change your fat efflux and influx. So for example, and to be honest, chemicals have different impacts in this arena. Some chemicals will increase your ability to make body fat. Some will decrease it. Some will increase your ability to break body fat down so you can burn it. Some will decrease it. But in general, when someone has an unfavorable chemical load, particularly if they're inflamed at the same time, it's going to shift your fat dynamics to the point where you actually get really good at making body fat and really bad at burning it for fuel, breaking it down and burning for fuel. And I mentioned earlier that fat cells can be healthy or they can be unhealthy. When cells are full of fat and they're big and they're inflamed and full of toxins, then they can produce inflammatory chemicals called cytokines, and they can dysregulate hormones like leptin or adiponectin, which have a lot to do with things like hunger and satiety signaling. Also, with the adipocytes, these chemicals can change energy regulation. It can decrease the ability of the cells to take glucose to produce energy, which is obviously important for any cell, including fat cells. And as I mentioned earlier, can increase insulin resistance or decrease insulin sensitivity. And the last thing that I want to mention here before we close this episode is the impact of chemical toxins on the ability of, to drive what we call browning of white adipose tissue. And again, this is not something that's well understood by most people, although it is published, of course, in the peer-reviewed literature. But we can also break down fat cells not just into location, like subcutaneous versus visceral. We can break them down by different characteristics. And in the literature, we call these different types of fat cells either white adipose tissue or white fat cells or brown fat cells. And what chemicals do is they reduce the browning of white adipose tissue, literally changing the color, but the color is not the important part. It's the functional change. So here's the difference and the distinction and why this is important. If we're talking about white fat cells, these cells are white in color when you look at them under a microscope because they have very little mitochondria. These represent the main storage depot for fat and toxins. They have a lower metabolic state, and because they have very little mitochondria, they're non-thermogenic, and they can easily get inflamed and become metabolically active. That's the kind of fat we don't want. What we don't want is white adipose tissue in your visceral space. We don't want a lot of these unhealthy, potentially unhealthy white fat cells surrounding all your internal organs. What we want is we want brown fat cells, which basically is the opposite of the white stuff. Brown fat cells have more mitochondria, they store less fat and fewer toxins. They have a higher metabolic state and they produce heat, which is advantageous to us. And they're healthier, but the problem is we lose these as we age. And if you look at the literature, people who have a higher proportion of brown adipose tissue in their entire fat mass tend to be less obese and they tend to be more metabolically healthy. And here's the cool thing, is that you can actually cause a browning of fat cells, of white fat cells, through different processes, different supplements. We'll talk very briefly. Well, actually, let me save that for the next episode because that's an interesting topic we can dive into a little bit. But what we want is we want to go through this process of browning our white fat cells. And again, the advantage is we convert potentially harmful fat cells that are pro-inflammatory and can store a lot of toxins into a much more healthier phenotypic expression of fat cells that store less toxins, is less or are less inflamed, and have less potential to cause issues and to cause problems for us. And again, we have some degree of control over that. And I'm going to save the discussion about some of the details and strategies that you can use, but I'll tell you one key thing, and this is something that nobody really wants to hear, is that the most powerful driver of fat browning, converting unhealthy white fat cells into healthier brown cells, or sometimes they call them beige cells, the most powerful strategy is exercise, right? Nobody wants that. Everyone wants to take a pill, take a drug. Nobody wants to say, okay, I'm going to start going to the gym 4, 5, 6 days a week, and I'm really going to invest myself in this. But we'll talk more about strategies of converting white adipose tissue into brown or beige adipose tissue in the next episode. Now, what did we talk about today? What I tried to do is just give you a general overview and some details about the third stage of the 3D detox approach. And it's important because If you're part of the Inflammation Nation, chances are just simply doing a detox the way most people think about it and prescribe it is probably not the way to go. You need to be more intentional, more strategic, and more thoughtful. And the third stage, DEEP-Tox, is about reaching into those deep storage depots in your fat cells predominantly, or organs that store fat, to draw out the stored toxins and then to repair some of the damage that's been done to the cell through the nature of the chemicals themselves or through some of the chemical consequences, things like inflammation, oxidative stress. So that's a quick flyby of the DEEP-Tox phase of the 3D detox. Now, this is a reminder that I did, if you listened to the last episode, I did put a couple of the handouts that I use in the 3D detox course that you can find on my website. And if you go to the homepage, you can scroll all the way down to the very bottom of the first page on the website, and that's www.drnoseworthy.com. That's drnoseworthy.com. And you can just put your email address in there, and you can download some of the handouts that we talked about in the last episode. Alternatively, if you look in the description of the podcast here, especially if you're looking at it on my website, there should be a link directly to a page where you can put in your email address and let me know where I can send those to you. And I hope you take advantage of those things. All right, guys, thanks for listening. We'll talk to you next time on the Inflammation Nation. Thank you so much for listening to the Inflammation Nation. If you found this episode valuable, please rate, review, and subscribe to our podcast. Be the first to know when a new episode drops so that you can stay on top of your game. It also helps others like you find the answers they need. And why not head over to my main website, drnoseworthy.com, that's drnoseworthy.com, to explore my personalized functional medicine coaching programs, submit a question to the podcast, maybe take a quiz, or even reach out to me using the contact form that you can find there. We'll see you next time.